Hello, everybody out there in YouTube land. This is Mr. Ellison, and I want to welcome you guys out to another episode of Mr. Ellison's Math Minute. Now, today, what we're going to talk about is direct variation. Okay, now direct variation, it's just like it sounds. Direct variation. Direct variation is a relationship between variables in which one variable is equal to a constant times, and I put the little time symbol, the other variable. Okay, now in this particular instance, guys, we are going to be using, with direct variation, we're going to be using an equation known as y equals k times x. Okay, where y is one variable, k is the constant, and x is the other variable. All right, now, and it says right here, k being the constant. Now I'm going to go back to this one slide that I just did with direct variation, and it's all written out in words, but I want to show you guys how it written out in words, I expressed it as an equation. All right, now it's a relationship between variables. Okay, and these are variables. Well, all three of them are. Okay, well, these are variables, and that's a constant. Okay, in which one variable is equal to a constant times the other variable. Okay, you can take the words and put them into a nice, neat little equation. All right, now when we talk about direct variation, we talk about an instance where y is directly proportional to x. All right, now this is what it means. It means, note, it means that both x and y, they change in equal proportion or by the same quantity with each change. All right, now whenever you're talking about algebra problems and the slope of a line, there's a constant change between the y value and the x value that forms the slope. Each time it changes, and if you take those ordered pairs and you draw a line through them, it's straight, it's constant, it's unbreaking. All right, now we're going to go back in time just a little bit to your 6th and 7th grade math whenever you talked about ratios and proportions. All right, now K is a ratio. Okay, K is a ratio, and it is a ratio of the y variable over the x variable. All right, that's what it is. K is the change in y over the change of x. Now, I'm going to give you guys a couple of examples right here, just some basic equivalent ratios. Okay, basic equivalent ratios. For instance, our first ratio is 1 over 2. Now if we expressed that on a coordinate plane, this would be the slope of 1/2. In this particular instance, if we were doing direct variation, 1/2 would be the constant. It would be the number that goes here or here in the equation. All right, and now if we look at proportional ratios, proportional means the same or equal. All right, if I go from 1/2 to an equal quantity of 2/4, the change from 1 to the 2 at the top of the other ratio is a change of 1. On the bottom, from the 2 to the 4, from 1/2 to 2/4, the 2, you go 2 steps to the right. Now when to go from 2/4 to 3/6, the top number, which is the numerator, goes 1 space up, and then positively 2 spaces over. Okay, from 6 to 8. From 3 to 4 is 1 space up. From the 6 to the 8, 2 spaces over. From the 4 to the 5, 1 space up. From the 8 to the 10, 2 spaces to the right. And if you connected these ordered pairs on the coordinate plane, they would line up in a vertical line. Or they would line up to form a line, an unbroken line. All right, this is what's meant by proportional. Each one of those ratios right there is the same form of 1/2, but 1/2 is just the simplified form of those constant ratios. I'm just going to let you look at them for a couple of seconds for those of y'all that are taking notes. And also, if you want to, you can pause the video and at any time, and that's the wonderful thing about YouTube videos is you can always pause them. Okay, I'm going to go ahead and I'm going to I wanted to go ahead and go back a little bit to the basic ratios in math, just to kind of set the field, set the stage for what we're going to do right up here. We're going to have an example. Now, I wanted to set the parameters and some of the conditions that have to take place in order for an equation to be considered an equation of direct variation. Now, when you have a y equals kx equation, these are 2 things that must be met, 2 things that have to happen, or it won't be considered an equation using direct variation. One of them is the y-intercept, which will be b, it has to equal 0, okay? And it being on the y-intercept, okay? And it cannot be above or below the origin, which means the equation goes through the origin 0, 0. So if you look at a coordinate plane, you look in the dead center, 0, 0, your line has to go through those 2 points, those points right there, in order for it to be considered direct variation. Now, if you're ever given an assignment or a quiz or an exam, and they give you a list of equations and say, which ones have direct variation, you can automatically exclude the ones that don't go exactly through 0, 0. All right? Now, I'm going to show you something else here. All right. Examples of this. Okay, now we have a positive coordinate plane here, and where the line is going diagonal into infinity, and then we have another one here, and we have a full coordinate plane with all 4 quadrants, and we have a line going diagonally through the coordinate plane, and then we have a positive line, and then on this particular example we have a negative line going through the coordinate plane, a full coordinate plane, and then we have a positive coordinate plane here, and the line is less steep than this line here. But that doesn't matter. The steepness doesn't matter of the line. Whether it's positive slope or negative slope doesn't matter. Okay? What matters is these 4 examples have one thing in common. One thing. All 4 of these lines go through 0, 0. All 4 of them. If you see an equation like this, or you see a problem like this, and they ask you if this is a line of direct variation, you can say yes. Now, we've talked about some of the conditions that must exist for y equals kx, okay, for it to have any form of direct variation. Okay, and we've also talked a little bit about basic ratios so that you guys are a little comfortable with working with what we're going to be doing right here. Okay, now with this particular problem that we're going to do, we're going to break it up into little pieces. Okay, that way we're going to work one piece first, and then you guys can look at it and we'll talk about it, and then I'm going to keep a few of the pieces of that and then get rid of the rest of the work. That way we don't even associate it or get it confused with any of the other pieces for the second part. Okay, now the first instance, is if x varies directly with y and x equals 20 when y equals 5. And it says, in this particular example, I had it on a whiteboard too. X is 20, y is 5. Then the constant value is what? We don't know. But the lovely thing about this problem is, guess what they give us? They give us both of the variables. They give us x and they give us y. Okay? And now we have our nice tidy little equation, y equals kx. And we're going to plug in the y right here as a 5, and then we're going to draw our equal sign. And for our value of k, we're going to say, well, there's a question mark, we don't really know, so we're going to leave it as k. But for the value of x, we're going to say x is 20, so we're going to plug in k times 20. Now, we're going to, that was kind of messed up, that 20. Let me make sure. Now, we see that k is being multiplied times 20, but we want to get k by itself in order to find the constant, okay? Now, in order to do that, we have to take k and we have to divide this side by 20. And when we do that, 20 cancels out and we're left with k. So the constant equals, now we don't know just yet, but what we're going to do is, we know that in an equation, what we do on one side, we have to do it on the other side. We learned that from earlier maths, whenever we were learning how to solve equations. Now, so if we divide by 20 on this side, to get rid of it and leave the k by itself, we have to divide by 20 on this side. So we have 5 divided by 20, or we could leave it in fraction form for the sake of the constant and have it be 5/20 equals k. But we want to get a little more sophisticated than that, okay? We want to break this down into its lowest terms, okay, the top and the bottom. So we know that 5 is a multiple of 20. So, and 5 and 20 are common on top and bottom, so we're going to multiply the top and the bottom of that constant by 5. Okay, so if I divide 5 by 5, I get 1. And then on the bottom, I divide 20 by 5, and I get 4. So, 1/4 equals our k. All right? Good. So now, this is our, it says 1/4 equals k. Now we have our constant. So, 1/2 of this problem is already solved, okay? 1/2 of it. So what we're going to do is, we're going to click check mark. We've done that half, okay? And we're going to put k equals 1/4. Alright, k equals 1/4. Now, we know that these two constants are going to be the same. That's the lovely thing. So we're going to use the constant, we're going to use this little piece of information, and we're going to use that to solve for the missing number, okay? We don't even need to worry about that anymore, okay? Because we know that the constant is going to be 1/4 for this ratio and for this ratio, okay? They're both going to be 1/4. Now, so let's go ahead. Now, do we know what x is? No, we do not. So we're going to leave x the way it is, all right? And then it says y equals 8. Well, we know what y is, so we're going to plug in our lovely y equals 8, okay? And we're going to leave our equal sign there. We don't know what the x equals, but we know what k equals now. K is 1/4. Our constant is going to be 1/4. Now, so we have this form here, 8 equals 1/4 x. That's after we plugged in the numbers that we know. Okay? Now, we want to solve for that missing number x. Alright? Now, how many of y'all remember in order to cancel out 1/4 what you have to do? You multiply by something. If you said multiply by the reciprocal, you're absolutely correct. So we're going to take 1/4. In order to get x by itself, we're going to multiply this 1/4 because it's attached to the x and we have to get rid of it. We're going to multiply it times 4/1. Okay? And when we do that, cancels out here, cancels out there, and leaves x with us. Okay? X by itself. So we're going to bring the x down, bring down the equal sign. But, you know, like I said, what we do on one side of an equation, we must do to the other side of the equation. So we multiplied by 4/1, which was the reciprocal, to cancel this out. Or it's just 4. What we do on the other side is we multiply times 4/1, or we can just multiply times 4. So it's 8 times 4, and it equals 32. Alright, so we know what our missing variable was for this particular ratio. Alright? Now we're not done. We're not done. Okay, I'm going to give you like a few seconds if y'all were writing this to go ahead and write it. Now, the next thing we're going to do is we're going to take these two ratios, or constants, because both of those constants are a ratio of this quantity over that quantity. Okay? Now, we're going to do this. And if both the reduced terms, if we reduce these particular constants to lowest terms, if we get this number right here, 1/4, that means we did our job correctly. So let's go ahead and check it out. So we got y equals 5 and x equals 20. And then we also have the other ratio, which is 8 and then 32. Alright, now 5 is a multiple of 20, and both the top and bottom of this particular ratio or constant have 5 in common. So if I divide 5 out of the top and the bottom, I divide by 5 here and I get 1. 5 divided by 5 is 1. Now if I divide the bottom by 5, then 20 divided by 5 is 4. Uh-oh. We're doing well so far. Let's see if we get the next one. Alright? If this one turns out to be this, then we did it. We made it to home base. Alright, now we know the top and the bottom of this particular constant or ratio. It has 8 in common. Okay? So I can divide by 8 up here, and it will reduce the top part of this ratio. 8 divided by 8 is 1. And then 32, I divided it by 8 also. 32 divided by 8 is 4. Oh, look at that. Looky there. We got 1/4. Both of those constants turned out to be 1/4, what our constant actually was, what we said it was when we solved, given that we knew both of the values of the variables. We did the problem right. Now, what I recommend is look over this problem again. Go over this video some more, okay? Go over it, look at it, see how we did it, practice. Okay, take an example. Ask your teacher to give you some examples, or you can get online, or you can find some kind of site that has examples of direct variation. And you can take those examples and do them like we did them here. Okay, now I hope this video was very helpful to you. I hope that you were able to gain something out of it. If you were and you appreciate it, hit the like button there. And if you have friends that you go to school with, or someone who's helping you out with your homework, or helping you out with whatever assignments you have, feel free to share it with them and let them see. And if there's anything in there that in this video that you didn't see that you would like to see, just let me know, and you can send me comments on my blog, okay, or on my YouTube channel, and it's Mr. Ellison's Math Minute. That's the name of my video channel. If you get on there and go to Mr. Ellison's Math Minute, you will find me, and you will find all of my videos and things that I show. Okay, now I want to just say, you guys have a good afternoon or a good morning, and keep doing your math and keep working hard, and I will see you later.